now we want to test the machine to make sure that electrically it's okay. So the first thing we're going to do is we're going to calibrate our testing device, which our testing device here is an insulation continuity tester, commonly called a Mega. So with this we're going to test the resistance of the windings, and we're also going to test the insulation of the motor to make sure that we'll be able to handle the voltage that the motor is connected to. So first up we're going to calibrate. First up we're going to check the calibration of the machine. So what we do first is we're going to use it on the 3 ohms. We'll use it on the 500 ohm scale. So what we need to do first is we have a mechanical zero here and we have an electronic zero. So we need to adjust the mechanical zero so that when it's free sitting it's below the zero. So you can see here that because we're on the 500 ohm scale, that's going to be this bottom blue scale, and we need to zero the machine out. So now we've adjusted that to below zero. Now we're going to turn the machine on and short the leads out, and now we can adjust the electronic zero, and if we line the pointer up here in the mirror, then that will give us no error, which is called parallax error if you look at it on an angle. So that means if you line it up with the mirror you're looking at it direct on. So that's testing our 500 ohm scale. So now we're going to go to this test machine here. So we want to test, we're probably looking for a couple of ohms resistance in our windings. So we'll go up to the 20 ohm scale and we'll just see how accurate our meter is on the 20 ohm scale. So you can see here we're on the 500 ohm scale and it's reading 20 ohms. So that tells me we should be fairly accurate depending on the scale that we need to test the windings. So now we'll go and test the windings. So we have 3 sets of windings here. So we'll just find the pairs. Nothing there. Okay, so there is 1 pair of windings and we're getting 5 ohms. So we're getting 5 ohms there. So what we're looking for here is consistency in the windings. So here we have no continuity in this second winding. So we have a problem with that second winding. We'll go to the third winding and we see here that we have 5 ohms reading in this winding. So 2 windings are okay and 1 winding has an open circuit. Now if I have a look here, as I moved the meter I noticed that we have a loose terminal here. So if we actually go onto the terminal, so there we go. So there we have 5 ohms as well. So that means the 3 windings are okay, they're all consistent at 5 ohms. Okay, so now we're going to test the insulation of the windings. Now we're going to do 2 tests here. The first test is going to be to earth. So we're going to test the windings to earth. So for this we need to test at 500 volts. So firstly we're going to go up to the 500 volt scale, which is our red scale at the top here. Now to test our insulation resistance tester for this, we need to what we need to do here is to test the open with no load voltage of our tester. So we're on 500 volts. So we set our multimeter to DC volts because we're testing its DC at 500 volts. So that's our no load terminal voltage of the meter, of the mega, and it's 523 volts. Now when we load this up, we've got to test it at 1 megohm because that's the reading we want to expect. It needs to be greater than 1 megohm when we're testing it. So we set our tester up here to 1 megohm. Now at 1 megohm, our meter must maintain between plus 20% of the 500 volts or minus 10% of the 500 volts. So if we are between 600 and 450, then the machine at a load of 1 megohm, then the machine is okay. So you can see there we're actually reading 519. So that's well within the range. So, and you can see that it's measuring 1 megohm. And 1 megohm is what we're looking for in this test. We're looking for a reading greater than 1 megohm. If it's less than 1 megohm, then it doesn't comply. So here we go. So now we're going to test between earth, and we'll just test that we've got an earth, and between each winding, and we should maintain greater than a megohm. So this is 0, 1 megohm, and this is infinity. We would expect a high reading in the vicinity of infinity, and we can see there we have a very slight reading there, but it's well within the acceptable range. Okay, now there's one more. We've metered that reading the insulation to earth. Now we can meter between phases. It's a 400 volt motor. To one phase and earth is 230 volts, so therefore we use 500 volt scale. But when we're testing between phases, we need to be at 1000 volts. And here we're going to measure between the actual phases. And you can see there that there's no leakage between phases. So therefore, electrically this motor is fine. So all we need to do now is to replace the bearings and the seals and reassemble the motor. These are the actual stator windings, and you can see there they go through these segments. So therefore, and you see they're all lacquered because you really want these to be tight. Because of the magnetic field, if you've got loose wires, then the wires can move constantly through the operation of the motor and eventually can break.